Hey everyone, and welcome back to Idea Mechanics. Today, we're diving into a really cool, kind of counterintuitive idea from the world of engineering. Our lead expert here, Manu, is going to walk us through how the secret to some of manufacturing's biggest headaches isn't about adding more material, but about strategically adding, well, nothing at all.
So many of us think innovation is this random lightning strike, a eureka moment that you just have to wait for. But that's not how the pros do it. True game-changing innovation, it's a system. It's a process you can actually learn and repeat to get amazing results every single time. So, if you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next. Okay, let's get right into it. Now, to really appreciate the genius of what Manu is about to show us, we first have to understand the old way of thinking, the trap that so many engineers and manufacturers fall into. We call it the solid constraints trap.
For decades, the old way has been to just accept problems. We use solid materials, hope for the best, and then try to catch the mistakes later. It's a system that basically plans for failure and waste. But the TRIZ way, the way Manu here coaches, it's a complete 180. It's about designing reliability in from the very beginning, letting the material itself become the solution.
And this is the fundamental question that changes everything. It flips the whole problem on its head. Instead of fighting with our materials, what if we could design them to be our allies? What if the material itself could prevent the defect before it even happens? And that question leads us directly to the core of today's big idea, a concept our expert Manu calls engineered emptiness. It sounds a little strange, right? But trust me, this is where the real magic happens. It's about designing with empty space on purpose.
This whole concept is built on TRIZ Principle 31, Porous Materials. As Manu is pointing out for us, the idea is surprisingly simple but incredibly powerful. By intentionally making something porous, like adding tiny holes or channels, we unlock completely new abilities. Suddenly, a material can be lighter, it can absorb shocks better, it can even act as a filter. The emptiness becomes a feature.
And the best part? This isn't just some abstract theory. As Manu has laid out for us right here, it's a practical, repeatable, three-step process. You find the problem, you engineer the emptiness, and you get the win. It's a system, not a suggestion. All right, enough theory. Let's see how this thing works in the real world. Manu's got a fantastic first case study for us, tackling a huge problem in metal casting. Let's talk about the breathing mold. Okay, so picture this. You're pouring molten metal into a solid mold. That intense heat creates gas. Now, in a totally solid mold, where does that gas go? Nowhere. It gets trapped, creating these tiny pressure pockets and bubbles that completely ruin the final part. That means defects, rejected products, and a ton of waste. So what's the clever TRIZ solution here? Well, instead of trying to stop the gas from forming, which is basically impossible, you just give it an escape route. As Manu's showing us, the technique is gas permeability. We use special refractory materials to create a mold that is intentionally porous. And the result is just brilliant. The mold can literally breathe. The gas that forms just flows harmlessly out through all those tiny engineered pores. You go from a high defect rate to a perfect, flawless casting every single time. The problem wasn't solved by adding more complexity. It was solved by engineering empty space. Pretty amazing, right? But that's not all this idea can do. Let's check out another case study Manu has for us. This time, we're using engineered emptiness to fight a totally different enemy, vibration. Now, if you're in the world of high-precision machining, you know that vibration is your absolute worst nightmare. We're talking about tiny, invisible shutters that can completely destroy the surface finish of a super expensive component, ruining its accuracy. It's a massive barrier to quality. So the old school fix is to bolt on these huge, heavy, clumsy external dampeners. It works, but it's not elegant. Now watch what Manu shows us here. The TRIZ approach is so much smarter. Instead of adding something to the workpiece, we change the workpiece itself. We make it out of porous aluminum. And the innovation win is just fantastic. That porous internal structure acts like millions of tiny built-in shock absorbers. When vibration starts, all those little voids just soak up the energy, and it disappears. The result? A super stable process and incredible precision. We got a better result not by adding mass, but by systematically removing it. So let's just pull all of this together. What have we really learned from Manu in these examples? It's a fundamental shift in how we should think about solving problems, because sometimes the void is the solution. Let's recap the big wins. We saw porous molds that can breathe, eliminating gas defects. We saw porous metals that act like sponges for destructive vibrations. In both cases, the hero of the story was the empty space. It proves that the most elegant, powerful solutions often come not from what we add, but from what we intelligently take away. Reliability isn't luck, it's an architectural skill. So I want to leave you with this final thought. Take a look at the problems you're working on right now, the challenges that seem impossible. Ask yourself, is it possible that the answer isn't to add more, to make it more complex? Where is your biggest challenge waiting to be solved by adding a whole lot of nothing?